What's up, science fans, and welcome back to Summarize Science. Have you ever seen an AI-generated video where the background seems to morph and change randomly as the camera moves around? It's a common problem called a lack of scene consistency, but a new paper might have just solved it. Current AI video generators are great at making short clips from scratch, but they struggle to continue an existing video. As you can see from these diagrams of other methods, they typically only look at the last few frames for context. This gives them a very short memory, causing them to forget what the rest of the scene is supposed to look like, especially if the camera revisits an earlier location. To fix this, researchers introduced a new framework called 3D Scene Prompt. The core idea is to give the AI both short-term and long-term memory. It looks at the last few frames to understand recent motion, but for long-term memory, it creates a 3D map of the entire scene. Here's how that 3D map gets made. First, the system has to separate the moving objects from the static background. This multi-stage dynamic masking pipeline cleverly identifies anything that moves, like people or animals, and digitally erases them. This leaves behind a clean, static-only 3D point cloud of the environment, which acts as the AI's permanent memory of the scene. When it's time to generate a new video clip from a specific camera angle, the system renders an image from this 3D memory. This rendered image serves as a powerful spatial prompt, or guide for what the background should look like. The AI model then combines this stable background guide with the information from the last few frames, which contains all the recent motion. This dual conditioning approach allows it to keep the background perfectly consistent while letting the moving elements evolve naturally. And the results are impressive. Here, you can see a comparison where the camera moves away and then returns to an earlier viewpoint. The other method, DFOT, forgets the original scene and generates something completely different, while 3D Scene Prompt's result is incredibly consistent with the input video. This holds true against a whole lineup of other models. Notice in the red boxes how competing methods either lose the detail of the white wall or generate something completely different. In contrast, this new approach accurately remembers the wall and maintains consistent scene elements throughout the generation. So to recap, the key is creating a static-only 3D scene memory and using it to prompt the AI, combined with temporal information from the most recent frames. This elegantly solves the long-standing problem of maintaining consistency in longer, camera-controlled AI videos. This could be a huge step forward for applications like special effects in film, creating endless, consistent worlds in VR, and generating realistic synthetic data for training other AIs. That's all for today on Summarize Science. If you enjoyed this breakdown, be sure to like and subscribe for more.